So let's look at some more examples of verifying trig identities. And so we have this example here. And the first thing we need to do is choose which side to work on. And it looks like this side seems to be the more complicated side, so why don't we go ahead and work on that. And then we're looking at this thinking, what can we do with these trig functions? And then we realize, well, these are square trig functions, so why don't we use a Pythagorean identity? So this one isn't so bad. We know that the sine squared of x plus the cosine squared of x equals 1. So the sine squared of x is 1 minus the cosine squared of x. So that's what we're going to put in here. Okay. Now this one here, we're going to have to start off with the same thing. We have the sine squared of x plus the cosine squared of x equals 1. And we need a secant squared, so that's 1 over cosine. So we'll multiply everything by 1 over the cosine squared of x. So we get the sine squared of x over the cosine squared of x plus the cosine squared of x over the cosine squared of x equals 1 over the cosine squared of x. So this becomes the tangent squared of x plus 1 equals the secant squared of x. And so for this, we're going to put in the tangent squared of x plus 1. So coming down here, we're going to have the tangent squared of x plus 1 minus 1 times 1 minus the cosine squared of x minus 1. And that has to equal a negative sine squared of x. So the ones cancel out, so we have the tangent squared of x times a negative cosine squared of x. Does that equal a negative sine squared of x? Now for this one, we do know that tangent is sine over cosine, so let's go ahead and put that in there. We have the sine squared of x over the cosine squared of x times a negative cosine squared of x equals a negative sine squared of x. And the cosines cancel out, so we get a negative sine squared of x equals a negative sine squared of x. And there we are. Let's try another one. Let's say we have the cosecant of x minus the sine of x. Does that equal the cosine of x times the cotangent of x? All right. So in this case, we have to choose one side over the other, and it looks like I'm going to choose this side. This is getting pretty close. I mean, it seems like a lot of our previous examples, it was pretty obvious which one was more complicated. This one's almost pretty even, but I'm just going to go ahead and choose the left side. And the reason I'm going to do that is because I know cosecant is 1 over sine, so I'm going to go ahead and put that in there. So I have 1 over the sine of x minus the sine of x equals the cosine of x times the cotangent of x. Alright, I'm going to go ahead and combine fractions. So we have 1 over the sine of x minus the sine squared of x over the sine of x. Does that equal the cosine of x times the cotangent of x? So we get 1 minus the sine squared of x all over the sine of x. Does that equal the cosine of x, cotangent of x? Okay, 1 minus sine squared, that looks like, again, a Pythagorean identity. So we have, let's see here, sine squared of x plus cosine squared of x equals 1. I'm going to do something different. I'm going to substitute in sine squared plus cosine squared in for 1. That should be good. So we're going to have the sine squared of x plus the cosine squared of x minus the sine squared of x all over the sine of x. These signs cancel out, and so now we have the cosine squared of x over the sine of x. Does that equal the cosine of x? Cotangent of x. Alrighty, so then I'm going to go ahead and split this cosine squared. And let's see, we need one cosine out. So we have the cosine of x times the cosine of x over the sine of x equals the cosine of x cotangent of x, and that is cotangent, so we get the cosine of x cotangent of x equals the cosine of x cotangent of x. And there we go.